Welcome participants. This is the last lecture in week 11. In this particular lecture I am going to explain some of the complicated warp knit designs which is produced on multi-bar machines or double bed machines. Please remember, some of these structures are very complicated. I expect you to follow other literatures as well in the details. Although these structures are not used so much compared to 2-bar structures, but these structures are highly technical importance. So, in specific applications some of these structures are used. These structures are very complicated in nature and their lapping plan and lapping diagrams are also complicated. I have selected only a few samples which was available to me, and I will going to explain you how these samples were created using multi guide bar or double bed Raschel machines. So, let us move on. So, the first one is what we have covered in the last class was 2-bar construction. So, in 2-bar constructions we have seen the most common one was queenscord, sarkskin, lock knit, reverse lock knit, satin, raised loop and trichord. So, the lock knit was the most popular one, which has the lapping plan of 1012 in the back bar and it has the lapping plan of 2310 in front bar. So, 70 to 60% of warp knit production actually follows lock knit because it is very much used in intimate apparel and lingerie. Other structures also give some specific properties, especially if you go for queenscord, it has the no underlap. So, because of this the structure is very rigid, while the back bar is very high underlap. Despite that, since the front bar is making pillars, due to which there is zero flexibility in the structure and the structure is very rigid. Sark skin, the underlaps are there, but a smaller extent in the front bar. So, that is also very rigid compared to lock knit structure. If you go for more extensible structure, the satin is the most extensible one because it has the longest underlap in front bar. So, if you have more and more underlap in the front bar, you will get very high extensibility. So, in the previous lecture we talked about how the properties of different structures is controlled using the help of overlap and underlap, controlling their directions and the positioning of back and front guide bar lapping plan. But in most of these structures it has been decided that all the guides which is attached with both the guide bars are fully threaded. So, each single guides on each bar is carrying one yarn. So, and also most all the movement of the guides in all the courses are exactly equal. It means in the first course if the overlap is for one pitch, in the second course also the overlap is one pitch. So, the amount of movement or sogging movement in the each course does not varies. So, it results in very uniform structures, and also the warp beams were supplying the yarn at a constant speed. So, then only you will get more uniform type of structures from 2 bars. But in reality, despite having controlling overlap and underlap, also controlling the uniform warp release from the warp beams, we have the flexibility of changing the threading of guide bars. So, we can, instead of fully threading the all guides of a bar, we can selectively threads different guides of the same bar, or we can also change the extent of sogging randomly in the warp knit structure. Also, we can supply the warp at different tension intermittently during the fabric production. So, if we change any of these three, then you will get a different kind of a structure and a different patterns and different properties of the fabric will come on the surface. So, some of these fabrics I have selected for you and I am going to explain in the subsequent slides. To make these 2-bar constructions, you have seen how we make the pattern chain and then put it on the pattern drum. So, the alignment of links is very important. So, in even more complicated structure, the link arrangement or drum arrangement will remain same. The only difference is how you are controlling the warp tension and how you are controlling the threading in guide bar. This is just the schematic of so video of 2 guide bar structure. So, you can see the chain links for 2 guide bar. Now, let us move to some more complicated structure. The first one is the net structure. So, let me show you what do you mean by net structure. In a net structure, I have 4 types of fabric with me, which looks completely different. So, this is 4 types of fabric. So, if you carefully see these 4 fabrics, you will find there is a spacing between the loops is increasing from left to right. So, if you see the first fabric, if I zoom for you, it is highly dense because there is no spacing at all. But if you see the second structure, you can see the mess or the open space between the loops is bigger. If I go for even more bigger structure, this is here even much bigger mesh size, and here also you can see it is the mesh size is smaller compared to this one where the mesh size is bigger. We can also go for even much bigger mesh size. So, naturally all the fabrics are produced on the same machine, but we are getting different types of meshes in the fabric. So, how do we generate a net structure? So, in net structure, if you see, is basically we call this type of structure as a mesh structure. So, you will create a different kind of meshes or holes in the fabric structure. This was the highly dense loops, and this is the more porous one. This one is also, it looks like a rhombus, this looks like a hexagonal. So, here also the schematic, if you see, this looks like a perfect hexagonal structure. So, how do we actually create these type of structures? So, to create these type of structures, we do need only 2 guide bar on the machine, just like front and guide bar for lock knit or sark skin. The machine will remain same. Only what we need to do is we need to thread the guide bars selectively. So, in a regular warp knit structure where all the guides of each bars were filled with the warp yarns, but in case of net structures we have to leave some guides empty. So, what do you mean by that empty is, like if you see this particular structures, if you follow the path of black yarn. So, in this vertical line, if you follow my cursor, so in this vertical line, if you follow the black yarn, it is moving alternatively in 2 columns and then changing the directions. If you start from here, so it is moving in 2 columns, then changing to the next vertical line, moving in 2 columns, then coming to this side of the hexagonal. So, how do we actually make this? So, if you follow the lapping diagram of the black yarn, this will be look like this, or the white yarn. So, it is doing tricoat for few courses, then it is switching and moving to the next column and again making tricoat. So, in this way it is switching from one side to other side. So, this black yarn, or if you see the white yarn. So, this is shown for the white yarn. If you follow the black yarn, it is also doing the tricoat and then switching to the next column. So, this is done by the yarns which is attached with the 6th position. So, the guides at 6th position is doing these type of lapping movement. So, one guide which is attached with the back bed is following the path of white yarn, and the another guide which is attached with the front guide bar, it is making the lapping plan followed by the black yarn. So, this is how this structure is created. Now, the question is, if you see the 6th position guides, they are making the lapping plan like this. Similarly, if you go for the 4th position and 8th position, there also these two guides at 4th position from back guide bar and front guide bar, they will be also moving the exactly same fashion. So, if such pattern is achieved on the machine, you will realize the guide bar at position number 5 and 7 is not doing anything. So, the column which is generated by the needle between 4 and 5 position and the needle between 5 and 6 position, they are not connected at all. So, these two columns are not connected. So, this is because of that you will get this kind of opening, because the needle between 4 and 5 position and 5 and 6 position, they are not connected at all. Similarly, if you go at this position, the needle at 6th and 7th, they are not connected. So, between 5 and 6 this needle, and between 6 and 7 guide position this needle are not connected. So, since they are not connected, because of that you will get the second opening. So, this is how the net structure is connected. So, if you carefully see, the guide position at odd number, 3rd number, 5th number and 7th number has no role to play. So, no role to play means it is not carrying any yarn at all. So, it is just doing the swinging motion. It cannot provide overlap or underlap of any warp yarn, because no warp yarn is attached to guide position number 1, 3, 5, 7. So, if no warp yarn is attached to such position, because of that two adjacent columns will not be connected and a opening will be created in the fabric, resulting in net structure. Okay. So, if you see this particular net structure, the structure has two characteristics. One is net pillars. So, this vertical line, the distance of this vertical line is the net pillars, and O is the net opening. So, distance between two vertical lines, this is the opening. So, dimension of the net structure actually depends on what is the pillar you are achieving and also how much opening you are created. So, the opening is actually done with the help of transition. So, if you see carefully, here also after doing the pillar, it is actually doing the transition to the 3rd column with the help of closed loop, open loop and again closed loop. So, this is what is happening here also. So, after completing the pillar, the guide bar is changing the position along this side of the hexagon, and all guides are doing exactly the same sequence. So, all even number 0, 2nd, 4th, 6th and 8th are doing exactly same sequence. All odd number guides of both the guide bar is not having any yarn. Because of that, you will get gaps between connectivity. So, this is how you control the pillars and the opening in the net structure. In reality, you have a different way of denoting the net structure. So, in net structure actually you need to find out, not only you have to describe the position of guides, but also you have to explain which guides is carrying the yarn and which is not. So, plus both guides from bar 1 and bar 2 are threaded in this position. So, for example, if you see this figure, so 1st position and 3rd position both the guides are carrying the yarn, and if you see 0, 2nd and 4th position, which is denoted dash, it means the guides is not carrying the yarn. So, whenever we go for net structure, partially threading of the guides in each guide bar is important to create such kind of mesh structure. So, if you want to understand this, so this is your needle and this is your guide guides. So, during the threading you are not providing yarn to each guides, rather you are selectively or partially providing yarn to some of the guides in the guide bar. So, because of this, whenever the lapping is happening with partially guides, some open structure is created in the fabric, and due to which you are getting these kind of net shape, you are getting these kinds of net shape, because some of the guides is not carrying the yarn. In normal conditions, alternate guides of both the bars are left empty, and we create very uniform net structure. If you randomly select guides and fill, no concrete pattern of the fabric will be generated. The sequence of threading of each guides on each bar has to be properly selected for getting a particular type of net structure. Some other net structure if you are, which is very popular, is pin net and sand fly. So, in pin net, this is how it happens. So, it is based on tricot, 2 cross 1. So, 2 underlap and 1 overlap. So, the first guide bar and the second guide bar in the second position is doing 2 cross 1 tricot in opposite directions. So, this is how it is happening. So, one is doing overlap from right to left and the other one is left to right. This one is doing right to left and this one is doing left to right, okay, and you get these type of structure. And here you are leaving the guides in first, third and fifth position empty for both the guide bars. Okay. So, no yarns in guide position 1, 3, 5, 7. So, only even number is working and they are making 2 cross 1 tricot. If you see sand fly net, this is also same, and you are also leaving the guides in selected positions. So, the first guide is doing closed loop, open loop, then closed loop, then open loop, then closed loop. This is how it is following. So, it is a kind of atlas having combination of both closed loop and open loop. The other guide in the same position is doing the atlas in opposite direction. So, here closed loop in opposite direction, then open, then closed, then open, then closed in this way, and this is how in the first position and fifth position is also doing. So, here the even number position guides are missing, because of that the opening is created between these loops. So, in most of the times the net structures, the dimension of these meshes is dependent on how you are controlling the lapping movement of guides and what type of spacing or what guides you have left empty during the fabric formation. So, net structure parameters, there are two main parameters in net structure. One is the pillars, the vertical line of the mesh, and the O is the net opening. So, what is the distance between two vertical pillars, and the other sides are just the transition of guide bar from one pillar to next pillar. So, for example, if you see this particular a simple example, just to give you a hint how you can change the dimension of this mesh. So, here is the lapping position of both the guides, and in one case you are doing tricot for 5 courses and then you are doing the transition. You are just doing one transition with the help of one open loop, and then again you are doing 5 course of tricot. So, here the transition length is much smaller and this length is higher, the pillar length is higher, because you are doing 5 course of tricot followed by transition for only 2 courses. So, because of that the side length is very small. So, this one you can follow, this is the line which is made by this, and this is the side length which is smaller compared to the pillar length. If you want more uniform structure, then you need to give more transition time or more courses of open loops at this position. So, for example, if you see there are 6 courses of pillars, and then for the transition you are taking more and more open loops. So, because of that, whenever the transition is happening, the loops is getting stretch more in that particular direction, and that side is much higher. You need to have a very uniform geometry. The net pillars and openings can be controlled by the lapping plan, and the threading of guides has to be done intermittently. So, you have to thread one guide, and one guide next to the threaded one has to be kept empty. So, alternative guides is carrying the yarn, and this is how you create net structure. Now, let us move to the inlay structure. So, inlay structure is like, here the yarns are actually floating in the fabric structure. For creating inlay structure, the most easy way is the weft insertion. So, once the guide bar is at the back position, you can carry the yarn and put it at the back side of the needle. So, this is how you do the inlay. So, you put the weft yarn at the back side of the needle, and then you are doing the overlap and underlap. So, because of overlap, the weft yarn is locked between the loops. So, I have also made one simple fabric showing you how the inlay was created. So, you can see this is the inlay yarn which I have inserted in the fabric structure, and this is the part of the fabric. So, you cannot pull it out because it is held tightly by the underlap. So, let me show you how I created this. So, at the back side I put it, I have kept this yarn in the floating way, and once the guide bar switch from the back side to the front side, it automatically lock the yarn in this position. So, this is how you can create a inlay structure in a warp knit. So, weft insertion is one method. The second one is also 2 guide bar structure. Here the front one is making tricot 1012, and back bar is just doing underlap, no overlap. So, here they are 0 0, no overlap, 0 to 3 underlap. 3 guide bar structure, sometimes 3 guide bars can be there. So, front bar is making tricot, middle bar is just doing neither overlap nor underlap. So, it is moving in a straight fashion, and back bar is just doing underlap 0 to 3. So, this is how you create 3 guide bar structure. Similarly, even more complicated structures can be generated. So, here this is the front one, and the middle one is just doing the inlays, and back one is also doing inlays in a different way. It is made from 3 guide bars. Even you go for more complicated one. So, here the front one is making pillar, and middle and back one, other 2 guides are doing inlays. So, here also you can generate very uniform mesh structure. So, this is another alternative way you can use the inlays selectively to create mesh pattern. Introducing held loop. So, the other complicated structure is you can also get miss and tuck. So, like float or tuck, similar to the weft knitting, you can also hold the loops for 2-3 courses. Because of that, there will be a tension variation, and the different structures will be generated. So, as you have seen in warp knitted, the loop geometry is highly complicated because the positioning of underlaps, which is not providing equal tension to the each loops. So, because of that, you will get a different kind of pattern, and including with such a complicated underlaps, if you can play with the held loop, tuck loop or miss loop, you can get even more complicated structure. So, for example, if you want to create this structure, so you are doing the lapping of some of the guide bars, while the other guide bars is holding the loops. Okay. So, this needle is hold the loops for 5 courses, and because of that some opening is being created. So, somewhere you have more dense areas because more loops are being generated, and wherever you have more held loops, there the structure is more open. So, you can see how if you follow the movement of any needles, you can see here after 4 courses the loops are being generated. So, again for the 3 course no loops, only held loops, and this is how you create cut pressure or mispress structures. These structures are very complicated. You do not have to go in deep. If you encounter, you can just follow its lapping pattern. So, this is how the lapping pattern is decided, and you are controlling the held loop and controlling the miss and tuck in the structure to get more designs on the surface. Now, the last part is double bed structure. So, double bed structure is the structures which is created by using 2 beds. So, you can see here in double bed structure there are 2 needle beds, first bed and second bed, and the guide bar is actually switching the yarn from one bed to other bed. So, in double needle bed categories there are 3 major structure which is found in daily routine. Is first one is the 3D spacer structure, which is very common, especially in cushioning applications. These structures is very common. Tubular structure is also very useful in packaging, and the third one is pile structure. So, it gives you more soft feel. So, let us see how a double bed structure is created. So, in double bed structures naturally there are 2 beds and multiple guide bar. So, now the onus is on the guide bar to switching from one bed to other bed. So, if you see this guide, so first it is making loops with the front bed. After making loops with the front bed, it is moving to the back bed. So, when it is moving loops with the back bed, the front is resting. When it is making loop with the front bed, the back bed needles are resting. So, the connecting guide bar which connects the 2 beds has a different types of lapping pattern. If you follow this lapping pattern of connecting guide bar which is moving on 2 beds, this is actually synonyms to 2 different types of structure that is created by single guide bar if it is moving in same bed. So, for example, if you see here, the first guide bar is actually making the lapping with the front bed. In the next course it is making lapping with the back bed, again it is making lapping with the front bed, then back bed, then front and back. So, alternatively it is switching from front to back and back to front. So, if you selectively remove all the front bed lapping diagram, it is 1 cross 1 tricot, and if you remove all the back bed lapping plan, it is also 1 cross 1 tricot. But instead of making 1 cross 1 tricot consecutively in 4 courses, it is doing alternatively for each bed. So, first it makes the loops which is 2-3 lapping plan, on the front bed. In the second course it is making the lapping plan of 3-2 on the back bed, which is the first course of back bed guide bar. If you go for third course, it is 2-1 on the front bed. So, third is nothing but the second course of actual fabric, which is 2-1, then again back bed. So, the second course is 1-2. So, that is why this is 1-2. Then in the fifth course again it is following the movement of front guide bar lapping plan, and then it is switching to back, and then again it is moving to the front, which is 2-1, and then back, which is on the back side. So, the denotation is actually different compared to the normal notation of regular guide bar. So, regular guide bar actually makes all the courses in the same bed, but connecting guide bar in 2 beds is actually making courses in alternating bed. So, because of that it is switching from front to back and front to back, and rest of the lapping plan whatever is set as per the pattern chain links, it will be following for that particular bed. So, the lapping plan for connecting guide bar actually has to be written in the form of front back, then front back, then front back, and then front back, and this is 2-3, 3-2, then 2-1, 1-2, then 2 3 3 2, then 2 1 1 2. So, here for one course actually you have to write 2 lapping plan for connecting guide bar. The most simplest one which is used in double needle bed warp knit is pile fabric. So, here is the sequence of pile fabric. So, front bar is making the loops on the front bed. So, there are 3 bar. So, one bar is only making loops on the front bed. So, here if you see the bigger dot which represent the needles on front bed and the smaller dot which represent the needles on back bed. So, the front bar, if you see the front bar, it is actually making loops only with the needles of front bed, and if you see the back bar, it is making only loops with the back bed which is the smaller needle. Okay. And then there is one bar which is connecting both the beds, is the middle bar which is the connecting bar, which is making loops with front and back needles. So, it is making loops with the bigger dot as well as a smaller dot. So, the bigger dot is the needles of the front bed, smaller dot is the needles of the back bed. So, the connecting bar is moving to the needles of both the beds, while the front bar is only making loops with the front bed, back bar is making loops only with the back bed. Similarly, you can have 5 guide bar structure. So, here also you can see 5 guide bar structure. So, there are 5 guides, 2 beds. So, 2 guides is focusing only on making fabric development with the first bed, and 2 other guides is making only fabric with the back bed, and there is one connecting bar. So, again if you follow the bigger dot and smaller dot, so the guide number 1 is just doing underlap on front bed, guide number 2 is also doing pillar stitch on the front bed. So, these 2 guides 1 and 2 is focusing only on the front bed, and if you see 4th and 5, 4th is also making pillar only in the back bed, and 5th is also making underlaps, only underlaps in the back bed, and then there is a third one which is connecting both the beds, which is this one. So, this guide is connecting both the beds. So, it is moving on the bigger dot and a smaller dot. So, connecting both front bed and back bed, because the loops is being formed by the same yarn on both the beds. So, this is how the sequence is generated. So, once the fabric is being formed, you can simply cut the fabric at in this position and you will get a floating yarns on the surface, and it is having a pile structure. The other important structure is 3D spacer structure. So, 3D spacer structure is again you are making 2 fabrics on 2 different beds, and there will be one connecting guide which is connecting both the fabric layers. So, there is top layer and bottom layers, and these are connecting layers which is called spacer yarn. So, here also if you see the 5 guide bar is there. So, 2 is making on the front bed, 1 and 2 is making on the back bed, and third is the connecting one. So, it is similar to the pile one. In the pile you are cutting the fabric, but if you do not cut the fabric in the middle, it will be a 3-dimensional structure, it is a 3D spacer structure. So, in 3D spacer structure also there are a lot of possibilities. You can go for 6 guide bar which is most popular. So, let me show you one simple structure of spacer. So, now you can see this is the spacer structure. So, there are 2 layers. So, one is this one is front layer, okay, and the other one is the back layer, and they are actually connected with connecting yarn. So, this is your connecting layer. So, 2 layers are being formed on 2 different beds, and then there is one connecting layer. So, this is your spacer fabric. So, on one side if you see it is a mesh type of structure. So, you can clearly see it is a mesh structure which we just studied, it is a net structure, and the other side is the simple loop. So, it is just like a pillar. Okay. So, this is how it is created. So, in double bed warp knit structure 6 guide bar are used and 2 beds are used. So, on the first bed you can make any type of structure, it could be a lock knit, it could be a rhombic mesh, or it could be a hexagonal mesh. And on the other side, on the back bed also you can choose any type of structure. These are the lapping plans. This is the structure, you can see this is the bottom layer, this is the top layer, and then there are 2 guides, which is guide number 3 and 4. They are actually doing the connections. So, it is actually moving from front bed to back bed or back bed to front bed. So, this is how these type of structures are created. So, the structure I just showed you has the on one surface it is having rhombic mesh. So, this is the mesh, and the guide bar 3 and guide bar 4 has the lapping plan of this, which is the connecting one. Okay. The last one is the tubular fabric. So, this is the tubular fabric. So, here also you need 2 beds. So, 2 fabrics layers will be created on each of the bed, and from the ends there will be 2 guide bars which will be connecting just these 2 structures. So, here you can see, so on one side you are making 1 cross 1 tricot on the front bed, and the other side also you are making 1 cross 1 tricot on the back bed, and then there are 2 guides. One is connecting from left side, so which is connecting both bigger front bed needles and short needles, and here also the second guide, connecting guide, is connecting the other end. So, in this way you create a tubular fabric. Warp knit designs are really very complicated, and for any specific interest on any of such a structure, whether it is a net structure or pile structure or inlay structures or 3D spatial structure or tubular structure, you need to follow a specific references. In this particular series of lecture, it is practically impossible to go deep in such complicated designs, but hopefully if you are clear with warp knitting notations, lapping plan, it is just the selection of different guides and selection of different lapping plan for each of those guides, and selection of beds depending on what type of complicated structures you want to create. So, with this we are ending the lecture on warp knitting, because we have covered so many aspects. In my opinion, you should be focusing more on overlap and underlap variations for 2 guide bar structures, that is the core principle, and then you should follow for more complicated designs. Many useful literatures are available where you can go for such complicated structure. Especially 3D spatial structure is the most common one, and you will find a number of literature in this. From next week we will be focusing more on the application aspects of warp knitted and weft knitted structures. So, some of the research part which can be done in both warp knitting and weft knitting, we will be explaining some of those application areas in detail. So, thank you very much. Catch you in the next week. Thank you.